Hello students, a very warm welcome to Electrostatics lecture on electric dipole. Today we are going to get into a very interesting part of electrostatics, electric dipole, and a direct question was asked based on the concept in JEE Mains 2019. Alright, it's a very critical concept, you need to understand it very closely, and this will help you solve questions in JEE Mains. And I don't know, JEE in advance, maybe there would be a little advanced questions, but we will deal with primarily understanding what is electric dipole. And guys, you are on JEE English by Unacademy, India's leading and largest JEE test preparation platform. So do like this video, do share this video so that students in need may get access to this free of cost quality lecture. And that being said, students, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from a top-ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I have filed 25 patent applications in India and abroad. And guys, so we have started talking about electric dipole. So what is this electric dipole exactly? So this is a visualization of an like an oscillating dipole, and this is given this way. Actually, it does not work this way. But think about it. What is this dipole actually, and how this all behaves? So this is like having two charges. As you can see, there are like two charges being indicated. One with like blue and the other with red. It is as if there are like two charges that are like placed really close to each other. Okay, we'll start understanding this concept, and before that, let's have a look at some very interesting visualization to understand the electromagnetic field around dipoles. So typically a dipole can be indicated with an arrow. You'll understand what is this arrow. This arrow indicates the dipole moment, like the direction of the dipole moment, and this is how this field looks like. So yes, this is about electric dipole and its field around it. If you're noticing this, this oscillating dipole is having some electromagnetic field around it, right? And if we talk about the magnetic field is going to look something like this. Okay, around this dipole. Okay, this is the z direction. So you are watching the z plane, and what is happening over here is this xn, your dipole is placed on the x and y plane, and from the origin the fields are originating something like this, right? So I hope this visualization gives you an intuition there is some field associated with dipole. Let's start understanding what is dipole. First of all, it's a very interesting concept, by the way. And that being said, what is a dipole? Be sure to take down notes, students. Do not miss out taking down notes. It's a very important concept for your JEE Mains preparation and as well as JEE Advanced preparation, because you don't know where the question would be asked in your JEE Mains or JEE Advanced. So basically dipole is nothing but two unlike charges, with not necessarily two unlike charges. It can be a system of unlike charges. But the concept is something like this. When we are talking about dipole, there would be like two unlike charges with equal magnitude. So if you're noticing here, there is one charge over here minus q, and the other charge over here plus q. Both have been given same magnitude, and they have a small separation between them. Okay, like d. Generally, we denote this with like 2L. We'll come to this point. What is this 2L? Why are we making use of 2L? So there is a small separation between two like charges. Then we call them two unlike charges. One should be a positive and the other should be a negative one. And we say that this is the electric dipole. Alright, so what is the speciality of electric dipole? Electric dipole, if you have noticed, if you draw a surface around this electric dipole, what is the charge enclosed in them? Total charge enclosed in the surface. So this is a standard rule for electric dipole. So if there exists an electric dipole, the Q net should be 0. Yes, right? Q net is 0, which is nothing but what is Q net? Minus Q plus Q gives you Q net. You're basically adding the magnitude of charges or adding the charges. So yes, any system of electric dipole should have enclosed charge as 0. So first of all, if there would be a question, whether dipole exists, dipole only will exist if there is a small separation between unlike charges and you know what, the charges enclosed in that system should have net charge to be 0. Very important point. And when we are talking about electric dipole, typically these two charges, as you can see, there is a minus q charge over here and a plus q charge over here, and they are separated by a small distance. Always do remember this is a small distance. We talk about two axes. One axis is along the charges. They are going to be along the line of charges. If you're noticing, this line is passing through the charges. Sometimes this is taken as x-axis. Sometimes maybe it is just said that it is known as dipole axis. In this case, this x-axis is the dipole axis, but whatever the axis that passes through this charges, they should pass through the charges, then we call them dipole axis. And there would be like an equilateral axis, equatorial axis. Equatorial axis is what? Equatorial axis is that axis. So if you notice over here on the top, you can see equatorial axis. So what is an equatorial axis, students? An equatorial axis is nothing but it passes through the center of the distance between the charges. Okay. Let's say these charges are separated by a small distance d, and on this charges lies the dipole axis, and perpendicular to this dipole axis you can take a equatorial axis, and this equatorial axis would be dividing this distance d exactly into d by 2 and d by 2, right? And then what is the dipole center? Dipole center is nothing but if you draw a dipole axis and equatorial axis, they will intersect at a point which is known as dipole center. Isn't it? This is known as dipole center. Really simple. Alright. So that being said, instead of calling it as 2D, I can call this half the distance as L and the other half the distance as L. Try to remember things in terms of half the distance L and L rather than using D. We'll quickly understand why that is, but this will really be useful once we start moving into dipole based concepts. And it's a very important concept. Make sure you're understanding everything. So with dipole comes the dipole moment. So what's a dipole moment? See, these are like bunch of new concepts, so stay focused, students, and do not forget to call your friends on this video. It's going to be very interesting, and we will solve lots and lots of problem around dipole, and we'll take up also this JEE Mains previous year problem. Hi Jeshwara, good evening. No worries, stay tuned. So what's a dipole moment? Dipole moment is actually a vectorial quantity. We will start defining the dipole moment. First of all, understand that dipole moment is a vectorial quantity, which means it has a direction. What is the direction? Direction is going to be from minus q to plus q. Notice the arrow's direction, that is going to be the direction of your dipole moment. Dipole moment is different from dipole, guys. Electric dipole is basically, having any system which has net zero charges, and it should have unlike charges in them, and these unlike charges should be separated by a small distance, and it's a real thing. It's not an imaginary thing. Think about your molecules. There exists a dipole moment. Haven't you read that there exists a net dipole moment in water? Exactly, it's the same thing, right? So yes, if you're talking about electric dipole would also have electric dipole moment, which is nothing but the vectorial quantity which indicates the dipole, and it is product of magnitude of charges multiplied by the distance between them. It's basically the product of magnitude of charges and the distance between them. So in this case, if I'm just going to talk about the magnitude of dipole moment, so we will be primarily doing two things. One, identifying whether a given system is a dipole, and the other thing we will be doing is we'll be coming to know what is the dipole moment and what is the direction of dipole moment. Okay, this gives us a lot of information around the electric fields, magnetic fields. It's a quite an useful quantity. It's also very practical. It's not an imaginary thing, guys. I mean, like, of course, theory is an imaginary thing, But that being said, this thing exists in your molecules, like your chemical molecules, etc. There exists a real dipole moment. What is this dipole moment? Dipole moment is nothing but magnitude of charge Q. C. What should be the value of charge, this plus charge? It should be plus Q. The value of minus charge in this case should be minus Q. Right? So what should be your dipole moment's magnitude? It should be magnitude of Q into 2L. What is this 2L? 2L is coming because of the distance of separation, not because of two charges, but the distance of separation between them. So this is how we define dipole moment, guys. This is just talking about the quantity. The magnitude of dipole moment is nothing but product of magnitude of charges and multiplied by the distance between them. And do remember, dipole moment as such is a vectorial quantity. What is the direction? From negative to positive. So if you are getting a doubt in your mind, up until now you are talking about fields which are going to enter this Q charge, minus Q charge, and this electric fields which are going to exit plus Q charge. Okay. Does that mean this dipole moment is in the opposite direction to the fields propagating from plus Q to minus Q? Yes. So this is just like a quantity, just like any other quantity. We have defined a quantity known as dipole moment, using which we will be deriving more useful quantities. Basically a definition, like how you have a charge, you have an electric dipole, and with electric dipole comes electric dipole moment, which is a vector quantity, which is nothing but product of magnitude of charges multiplied by the distance. The distance should be small distance between them. Okay. And we generally try to use this as 2L. I'll come to this point later on. Why do we make use of 2L? So yes, and what is the units of electric dipole? So electric dipole moment, what is the value of electric dipole moment? Basically of magnitude of charges multiplied by some distance, which is nothing but length. Hence the unit is going to be coulomb meter. Going to be coulomb meter. Right? So yes, that is about dipole moment, and this is how you derive dipole. And what does dipole represent? Dipole is all about representing the strength of electric field generated by an electric dipole. What is the importance of the electric dipole? I told you, like, there are many molecules in which dipoles exist. So dipole tells us literally the field around those molecules. So electric dipole represents the strength of the electric field around those electric dipole. Okay. So yes, electric dipole moment represents the strength of electric field between electric dipole. This you will understand as we start deriving the electric field. Now comes the question, a very interesting question for you to think about. So this is my question. Okay, students. So think about it carefully. So now this electric dipole has minus Q and plus Q in it. So let's say I'm drawing a Gaussian surface, like it's like a cylindrical Gaussian surface or something, and what I'm asking you now is, if I'm drawing this surface, what is the net charge? If you remember, an electric dipole should have net charge equal to 0. This is also 0 in this case, right? So does that mean Pavan, good question. 2L is constant. 2L is the distance between the dipole, Pavan. Okay, Pavan has a good question, that why 2L is constant. 2L is constant because it is a fixed separation between them, but that can be also an oscillating dipole. But we are just starting with the basic of it. Now comes my question. So if you draw, like a Gaussian surface, and what is happening? The net charge enclosed in is 0. Some, this is like a different kind of Gaussian surface, but it can be like, cylindrical, spherical. You can also think about a spherical Gaussian surface around these two charges which are separated by small distance. Now the question is, can we apply Gauss law in this situation? So what does this question say? A says that the Gaussian law cannot be used to calculate electric field near an electric dipole. So Gauss law says that electric flux is equal to Q enclosed by epsilon naught or epsilon. Now in this case, Q enclosed is 0 divided by epsilon naught, it should be 0. That means flux should be 0. If flux is 0, field should be 0. Because what is electric flux? Basically, flux is nothing but field multiplied by area, basically E dot A. It's a dot product of electric field and area vector. Does that mean in this case, electric field inside this Gaussian surface is 0? So the statement says that Gaussian law cannot be used to calculate the electric field near electric dipole, and the B statement says electric dipole does not have symmetrical charge distribution. So statement A says, if you draw a Gaussian surface, the net enclosed charge is going to be 0, and does that mean the Gauss law is not applicable to calculate any electric field near electric dipole? Because we said in the earlier statement, if you remember, electric dipole represents the strength of the electric field generated by electric dipole, right? So does that mean we can't use Gauss law to calculate electric field? What is the reason? Does it mean that the electric dipole does not have symmetrical charge distribution? Is that the reason? So your option A says both A and B are correct. B is the correct reason for A to be true. Both A and B are correct, but B is not the correct reason for A to be true. Only A is correct, only B is correct. Think about it. Hi Ayush, hi. So here is the question. We'll discuss this concept at the end of the lecture. Stay tuned until the end. We will get to know about it. Can we use Gauss law around electric dipole? If not, what is the reason? Then you would really love to understand what is this electric. Start working around it, think about it, keep it in the back of your mind. It's going to be very interesting, guys. And that being said, the most competitive gamified IIT JEE battle ever is going to get started. I mean, it has already begun. The next one is going to happen on 6th of December. So you can compete live and win lots of rewards and prizes. So enroll today with Murli live code. Do not miss out the Murli live code and enroll right away, guys. Enroll right away. It's going to be super competitive. It's going to be useful for your JEE examination. It's going to be also rewarding because you can win Amazon vouchers, hundreds of Amazon vouchers, and not only that, you can also win, guys, Apple products. So apply Murli live code while you enroll and make sure you are enrolling to Unacademy Combat. And that being said, students, get onto our Telegram app because I keep you posted with very interesting information around every day's lecture. For an example, today is about electric dipole and what is the significance of electric dipole and how is this asked in your exam. These kind of things I keep posting on your Telegram channel. So first of all, download your Telegram app from your Google Play Store and App Store, and then click on to this link which is available in the description box below. And then, guys, just get onto our Telegram channel and you will get live before time updates on every class happening on JEE English, any lecture conducted by our JEE English lecturers also on Unacademy Learning app. And yes, you can just type in also JEE_English if you have Telegram app. Alright, so yes, this Sunday we will be having a special class on like capacitors, and this is going to be a problem and PYQ session on capacitors. So be sure to attend this class. It's a free of cost special class which is going to happen from 10 a.m. to 1 p.m. Guys, make sure you're attending this class to know about your PYQs and capacitors. We have already completed the A to Z series. This is of course a part of A to Z series. A to Z series on capacitors is complete with all the concepts and all the model problems that you need around capacitors. Make sure you're covering capacitors along with your electrostatics. That way you're able to maintain the completeness. Both of these topics go hand in hand. And yes, that being said, students, 2021 and 2022 aspirants, make sure you have attended units, dimensions and measurements. So these are like 4 back-to-back sessions that was conducted plus 1 model problem session. And students, these are all again available for free of cost. And with this A to Z lecture series, your preparation around units, dimension and measurements would be complete. We have discussed units based problem, dimensional analysis, measurement based problems, least count based problems, Werner calipers, screw gauge, etc, etc. And why is this topic important? Because it's an easy scoring topic that also consumes not less time during your preparation but also during your exam. So yes, and definitely one question is asked every year in your JEE Mains. Combine both of your sessions of JEE Mains and JEE Advanced, you can expect 3 questions, and definitely the easiest one. So make sure you're attending this recorded lectures. They are not live lectures, but still you can attend the recorded lectures and learn from them. So make sure you're attending them, and do come to regularly to the special classes and JEE English, so that you can get concepts completely and in-depth manner. And that being said, if you don't have an Unacademy learning app yet, just download it from your Google Play Store and App Store. Just type in Unacademy, download this Unacademy learning app. Once you type in Unacademy, you'll find the Unacademy learning app as the first search result, and click on that install button, the most downloaded education app. So that being said, students, if you are looking for a champions tool for your JEE Mains and JEE Advanced preparation, it is going to be your Unacademy subscription. Why is Unacademy subscription the best thing for your JEE Mains and JEE Advanced preparation? Because we have the best educators across the nation on one platform, and not only that, we also have the best program for your JEE Mains and JEE Advanced preparation. So you will undergo like a dynamic structured program in a very systematic manner, where you don't have to worry about your test preparation. It's not just about lectures, it's also about your test series. You get to attend structured classes with the best educators across the nation, where you will have dedicated doubt clearing classes, dedicated quizzes, mega quizzes. Not only that, students, you will also get to attend national level test series, and of course, best educators, best program, and the best platform, a very interactive platform where you will love to enjoy the way you are learning. And yes, all you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and we have programs for both JEE Mains and JEE Advanced, and click on this get subscription button. And the amazing thing is, it's one subscription, unlimited access. So that being said, guys, the price is also pretty low. All it's going to cost you is less than 2,100 per month to purchase an Unacademy subscription, a 24-month package. And this all comes at, if you ask us, it's only 70 rupees a day. Right? So yes, this is a 24-month package typically meant for 8th class, 9th class, 10th class and 11th class students. Do not forget to apply Murli Live coupon to avail the best discount on your subscription purchase. So get the best discount on your subscription by applying Murli Live coupon. And that being said, students, you can split your payments into multiple parts. We have convenient payment options for you, like pay in parts and no cost EMI, which you can make use of to split your payments into multiple parts. And guys, the amazing thing about them is you don't have to go through the hassle of paying all the fee at once. You can split your payments into multiple parts, and you can pay them on month by month, and these are like easy monthly installments without any interest. And we do also have other payment options like debit card, credit card, UPI, which you can make use of. And students, if you are in 12th class, or if you are a long-term student, or if you are a dropper, this is the program for you. And yes, what do we have for you as a dropper? We have dedicated droppers batch going on, micro courses going on. Not only that, students, we have 6,000, 7,000 plus materials for your JEE preparation, and more importantly, we have 1,000 plus live programs going on right now for you. And students, this all comes at a price of less than 2,900, only at a price of 2,888. And you need to apply Murli Live coupon to get to this price point and to avail the best discount on your subscription purchase. And students, not only that, this is all about plus, but we also have something known as iconic subscription. So what is the beauty of this iconic subscription? What do you get in this iconic subscription? In iconic subscription, you not only get best educators across the nation and daily live interactive classes with them, not only doubt clearing sessions, but structured programs and PDFs are also available as they are available in plus. But along with that, you will get personal coaches, study planners and expert guidelines for your JEE preparation. So think about it, you will be learning not only from IITians and NITians, but also you will be getting to get your doubts cleared from them. You'll be getting the personal coaching from them, which means you'll exactly know the path to crack your exam. And this all comes at a price of 50,400 if you go for a 12-month subscription, and if you go for a 24-month subscription, it's going to cost you 77,400. Be sure to apply Murli Live code to get the best discount on any of your subscription purchases. Right? So yes, our iconic team, that is our team, JEE English team, is also available on iconic subscription, and you can take your JEE preparation to the next level with your personal coaches. And make sure you are attending these sessions. If you are on iconic subscription, you get to attend IIT JEE workshops, expert guidelines, study planner, test analysis, more and more with our JEE English team. And we have IITians, NITians and head of institutions on our. And that being said, students, if you are already on Unacademy subscription, enroll soon to this Optics Basics to Advanced coursework, where you will get to learn all of the optics in this plus course. So yes, it's a comprehensive course on optics and it has just been launched. You can still attend the recorded classes. Everything from basics to advanced is what is covered in this Optics B2A Basics to Advanced coursework, a comprehensive coursework on optics. And that being said, do not forget to like this video. Do not forget to share this video. Practice, practice and practice only makes human perfect. But that being said, we are on dipole, which is a concept. Right, so yeah, it's a concept oriented topic, so let's get into it and get started with problems. Okay, the best way to understand your each and every topic is going to be through problems. Of course, this is what we are going to do with dipole as well. Okay, so yeah, get started with the question, students. The net dipole moment of the system shown with charges placed at the center of the square with side of A is how much? Do remember, your dipole is a vector quantity. Make sure you are making of every such thing told to you. So have a look at it. Get started on the question. I'll wait for a couple of minutes so that you can look around the question. You can look around the question and you can work on it. But let me tell you, draw the direction of dipole. That is also very important. Even though your magnitude is being asked of the net dipole moment, but still you need to understand it from the vector perspective, okay, because it's a vector quantity, right? So there are 4 charges that has been placed as shown, 1 plus q on one side, minus q on one side, so alternating plus q minus q on the corners of the square. Get started on it. Try it out. All right, let's move on then. I believe if you're watching the video, start commenting, students, start answering it. You need to understand what is going on. All right, let's get started. It's a vector quantity. Okay, first of all, let me ask you a question over here. What is the dipole moment? You can choose any of the pairs. Right, first of all, whether the system is a dipole system or not. Verify that. What is the net charge enclosed in this system? Is it 0? Check it out. Check it out if it's 0 or not. Check it out, students. 0, right? So does that mean this is a dipole? This is minus q plus q 0, minus q plus q 0. This is a dipole. Now you understood that part. How to calculate the dipole moment? So two system of charges, what you used to do, you used to say dipole moment is nothing but P is equal to magnitude of charge multiplied by that separation vector. We used to call it as 2L, and that did go from where to where? Minus to plus or plus to minus. It went from minus to plus. All right. Now comes the question in your mind. How do I calculate dipole moment of the system? Remember, it's a vector quantity. Okay. First of all, you can choose any 2 pairs of unlike charges to bring up an electric dipole. You can either choose these 2 charges or you can choose these 2 charges. Right? Or you can also do the other way around. You need not necessarily choose those charges. Really important, try to understand it. You can also choose these two charges. This is also a pair, and this is also a pair of unlike charges with the same magnitude. Hence, they would be forming a dipole. Now, right? So, two dipoles. I'm going to do this one, right? This one looks same, but there's no difference. Just to give you an understanding. So, this is minus q plus q dipole. This direction. What is the value of dipole moment, guys? Let's call this as P1. P1 vector is going to be something like, let's say this distance is a. It's already given to us a and a. So 2l was nothing but distance of separation between them. It's q into a vector. What about dipole moment 2? This is going to be P2, which is going to be like q into plus or minus a vector. What is the net dipole moment of the system? Net dipole moment of the system is addition of P1 and P2. What do you get that to be? Q into A, right? Minus of or plus of Q into, from here you can see what is this? Q into minus A. Why is that minus A? Because charges are arranged other way around. So here your dipole moment was from negative to positive, from left to right to left, whereas in this case it was left to right. On the above case it was from left to right, and in the case below it was from right to left, negative to positive. Simple. Add them both. What do you get? Q into A, Q into minus A, 0, guys. 0. 0 is the net dipole moment of the system. Clear? I believe this should be clear. That is it. 0 is the net dipole moment of the system. So this is how you work around when you are given individual charges. Write down dipole of each pair of charges. One pair, one dipole is formed. Then you need to take up other pair, other dipole is formed. You will find the dipole moment of each pairs, like how we did over here. One dipole moment pair, another dipole moment of the other pair, and just okay. Now let's come into another interesting question. Now the same square. Now 4 charges are placed, but in a different arrangement. If you notice over here, plus q is over here, plus q is placed adjacent to it, and then there is a minus q placed next to each other on the opposite corners or on the opposite side. Okay, now what do you think will dipole moment be? Choose any two system of charges that make net charge to be 0 to form a dipole pair, and find the number of dipole pairs, add the dipole moment of individual dipoles, and come up with the result. If we have plus q and minus q over here, we can say this is one dipole which has dipole moment something something, and this is next dipole which has dipole moment something. Sides are a, all the sides are a. Okay. If I'm going to call this as P1, what is the dipole moment? P1 is equal to magnitude of charge into distance between them, added with the vector. And this time we can say something like this. Let's take care of the sign convention this time and write it as a vector quantity, because earlier it was little easier one. This is also an easy one. So what is the direction of dipole? Negative to positive. This is the direction of dipole. Right. Okay. Understand this point. What is the direction of dipole? In this case, from negative to positive, minus x cap q into a minus x cap or minus I cap, however you like to call this. If I'm going to say this is the x-axis and this is the y. Now comes the next one. What is the dipole of this pair? The same as this one, right? The same as this one. If I'm going to call this pair as dipole moment of this pair as P2, this is going to be same as q into it's minus x, right? Minus q minus of q into a into x. Minus is coming due to this. So this dipole will also be in this direction. What is the net dipole moment, students? Net dipole moment is going to be P1 plus of P2. Is that it? How much do you get this to be? Minus q into a into x cap minus or plus of minus of, again the minus sign will be there. Minus sign does not disappear anywhere. You will have this. How much does this come out to be? Minus 2 into q into a into x cap. This is what? This is net dipole. Okay. I believe you understood it. Earlier one it was 0 because the charges were placed on the opposite one of the charges were placed on this and the other side. Now this time all the dipoles are moving from right to left, be it on the top or be it on the bottom. So this is the magnitude of net dipole moment, vector quantity. But what about the magnitude of this dipole moment? This is the value of dipole. Okay, magnitude of dipole moment is going to be 2q into a. Simple as that. Simple. Alright, answer should be A. Alright. Let's move on to the next problem then. Now, this is a very interesting part that you need to understand. Okay, there are a few things that you need to understand very close. Dipole moment, vector quantity, not a scalar quantity. So what is the dipole moment of the given system where minus q is placed over here, plus 2q is placed over here, minus q is placed? How would you work around such problems when you are not given any individual? Does this kind of system exist? Yes, of course. Okay, this is like a 90 degrees angle between these two charges, arrangement of the charges. But there are many such systems which exist. Okay, try it out on your own once and get started. So I'll quickly explain you something known as, remember, water molecule is a polar molecule which has net dipole moment. Right, negative to positive. Let me do a thing. Let me illustrate you something interesting. So yes, one is going to be from negative to positive, other is going to be also negative. Is there a net dipole moment? Yes, there is a net dipole moment in water molecule. Water molecule, if you remember, has a dipole moment. And what is this? This is minus 2. This is plus. Right? This is having a dipole moment. Isn't it, guys? Yes, it does have a dipole. Now, if that is being said, okay, that is not bad. Dipole moment, how do you calculate the dipole moment? It depends on the angle and the magnitude of charge. Alright, this is for an individual H2O molecule. Now let's come to our case. Now in such cases, when you are given, plus 2q and minus q like this, what you have to do is, first of all, imagine it as if there is a plus q over here and a plus q right adjacent to it, I mean like on the same side, etc. Just think about it as if, two plus q's are placed one over another, and this a minus q. And there is a minus. Now guys, this is how you have to approach any given dipole based problem. Okay, so I think this time we'll take I cap and j cap. What is the distance between them? Okay, so split the charges. So think about the charges as if they have like plus 2q charge that can be split into two individual plus q charge, and first of all see whether the system is and have a dipole moment by assessing like whether the net charge enclosed in is 0. Okay, so that is it. With this, what needs to be done? We need to calculate the dipole moment. What is the dipole moment of this system over here? Okay, let me start from the y-axis side of it. So I'm going to call this P1. What is the value of P1, guys? Going to be Q into A into minus j cap, right? And then there is this another dipole which is moving in which direction? Dipole moment which is moving in which direction? Dipole moment is in minus q into A into minus I. That is it. So what is your net dipole moment in this case? As a vector quantity, it's P1 plus of P2 vector. What does this give you? This gives you something like Q into A, you can take out as common, minus I cap minus j cap. That is it. Now you have, this is exactly the value of dipole moment, or what is the dipole moment? This is the dipole moment, Q into A minus I cap minus j cap. Now coming to the part where you have to calculate the magnitude of the dipole moment, what would you do? You would basically take a mod of P net. Okay, so that would be under root 2 QA, right? That is it. Easy. All right, so whenever you're given a charge, like a system of charges, first of all draw, not draw but just calculate the net charges and see if dipole moment exists. If dipole moment exists, then split those charges with larger magnitude into how many ever number it is required, and draw the dipole moment as the vector quantity and assess the dipole. Easy. All right, let's move on to the next question around dipole. Then we'll soon get started with the JEE Mains question. If you understood this one, we can also answer this one, which is not a big deal. And what is the direction of dipole moment? We just did it, right? One is going to be in minus I, same magnitude. The other one is going to be in minus j. If they were of different magnitudes, let's say this was like plus 3q and this was like minus 2q. Let's say instead of plus 2q, this is like plus 3q, things would change. I'll come to that point. What would happen if this was like plus 3q and this was like minus 2q? But in this case, as we calculated earlier, what would be the direction? Minus I minus j. We just derived it, right? We just calculated it. Right? This should be the direction of the dipole. Okay. Because your one is going to be from minus q to side. This is now comes a very interesting question. So what if instead of 2q, this was like a 3q? How do you really find out the direction? Not not literally just saying that it is minus j and it's going to be like minus j and minus I. Instead, this is going to change. Okay, now carefully think about it. What is the dipole moment in this direction? 2 into q into minus j cap. What about in this direction? It is still q into a into I cap, minus I cap. Now, thing is, what is the direction in this case? Okay, let's call this as P1, let's call this as P2, dipole moment 1, dipole moment 2, net dipole moment in this case is going to be P1 plus that of P2, all vectors. How much do you get this to be? 2 into q into a into minus j minus of, or this is actually, let's keep this plus for now, q into a into minus I cap, right? So this is going to be how much? Q into a minus 2j minus I cap. If I'd asked you the vector around them, how would you calculate it? Direction, what it would be? It would be, this is a vector. How do you do this, students? Simply take a P net cap. What it would be? It would be vector P divided by, okay, let me move on to the next page. Just take down these values quickly. An example, plus q and minus q, 2q. This is still a dipole based system because you have net charge 0. You can see two dipole pairs, hence this exists. Now let's move on to calculating the dipole moment. So we found out P net vector to be something like qa into minus 2 j cap minus I cap, which we calculated just now. So if I am going to ask you the direction, then you are going to do P cap net, which is going to be q into a minus 2 I cap j cap divided by q into a under root 5. Right? How did we get this? We just did P net divided by magnitude of P net, unit vector. That's it for the direction. Do this, qa gets cancelled. Basically going to be something like P net is going to be minus of 1 by root 5 2i plus j. Direction of our dipole. Okay, if this was plus 3q and this was minus. Easy. That is it. All right, guys. So yeah, no question is asked around that, but this is how you assess the direction of dipoles. First of all, calculate the net dipole moment, and then you know how to work around finding out unit vector and the direction. Not a minus a minus to give you an understanding of So now let's say we have a system where the net dipole moment is asked, and again plus 2q charge, and you have 60 degrees between the arrangement. Earlier it was 90 degrees, now it is 60 degrees. Earlier it was like two lines that are perpendicular to each other. Now these are like one is inclined at an angle 60 degrees. Think about it carefully. Start working around the problem. We get started. You know the answer, guys? What's the answer? How do you work around this problem? Apply some vector map. Okay, let's get into this problem. So you have plus 2q, which I'm going to write down as something like this, as plus q, and another plus q. Split the charges whenever necessary, and you have some minus q and another minus q, like right. There should be dipole moment, of course, if there are a pair of charges like this, and one is going to have something like this. Distance of separation is same, a and a. I'm going to call this as like p1, to positive. To call this p2. So one thing, if you observed, both of them have same magnitude, right? What is the magnitude of p2, guys? The same as magnitude of p1, isn't it? How much is that? Like q into a. Magnitude of charge multiplied by its distance of separation between them. That is it. Now comes the next thing. Okay. What is the angle between them? 3 degrees. So how do we calculate the magnitude of the dipole in this case? We say something like this: P net is equal to under root of P1 square plus P2 square plus 2P1 P2 cos theta. What is the value of theta, guys? Theta is 60 degrees. Theta is how much? Actually, if you notice, your dipoles are not like this. I mean, not making 60 angles like this. They are actually making 60 angles, something like that. Okay. This you need to extend it. With this you need to extend it, okay, to find out the angle. This is P1. This is P2. Right. So how much is this angle? This is the same as this one. Opposite angles, like this would be also 60. Okay, anyway, do the math. So this would be like, if I'm going to say the magnitude of this instead of q, I'm going to keep it as p, and now like a scalar quantity p, and finally I'll substitute the value of p, and theta is 60 degrees. I know that. So you guys also know this, that this is going to be p square plus 2p into p into what? Cos of 60. Now, yeah, this is now a problem of vector math. So cos 60 is how much? 1 by 2. So this is going to be p square plus 2 into p square, or 2 into p into p into 1 by 2, 2 gets cancelled out. How much do you get? This added up, you will get something like 3p square under root. This is magnitude of P net. How you do in your vector is the same thing. If I'm going to ask you what is the magnitude, P net going to be 3p square under root to be p root 3. Coming to the direction part, how do you do the direction? Same way, you need to write down the vectorial expressions for each one of the dipole. Okay, this is just about the magnitude, but I question it was about magnitude, but we are discussing the as well. What you're going to do is say this is p1, this is p2. Let's do a thing. Let's assume along this p1 we have when little like in the opposite direction of p1 we have the x-axis, and in the opposite direction of the perpendicular direction to that of p1 we have y-axis. Now what is p1 is how much? Magnitude of charge is q into a into I cap minus I cap now, right? Minus I cap, isn't it? What about p2? P2 is going to be q into a. Now here lies the question, how do we do this? Can we say something like this is this p2 divided into 2, and along this is going to be 60 degrees. Okay, this along the y-axis is going to be how much? Cos theta minus I cap, and this is going to be sin theta minus j cap. Right, again, if this is a little confusing, so yes, just add the term in the brackets, that's it. It will be like cos theta minus I cap plus of sin theta minus j cap. What this value should be? What is the value of theta in this case? You know, it's 60 degrees. Q into a into cos of 60 1 by 2 minus I by 2 minus of sin of 60 root 3 by 2. This is what? This is P2, isn't it? Right. And this what? This is. So now instead of the magnitude of the dipole, if I had asked you what is the net dipole moment, you are not going to say this p root 3. Okay, p root 3 in this case is qa into root 3. So substitute the value of p from here. You get that magnitude of p net much p root 3. What was the value of p? A root a. Next comes our direction part. We are more worried about. This is p net. How much is this? Basically p1. So we add the vectors. What do you get over here? It's something like QA minus I cap and minus of or plus of QA into minus I cap by 2 minus root 3 by 2 J cap. End of the story. P net is equal to QA into minus 3 by 2 I cap minus of root 3 by 2 I cap. That is it, students. This is the net dipole moment. What we calculated earlier was not net dipole moment but rather magnitude of net dipole. Okay, believe this should be clear, and this is going to be what? Net dipole moment, a vector quantity. Believe this is clear. From now onwards, we need not do this. Hi Neelu, hi. Amazing, you understood it. That is it, guys. So if you're understanding this problems, then JEE Mains problem is going to be super easy for you. It's little moving out of this track. I mean, like not the same one. Rather, you will notice something else. But I discussed that case as well. But there is something in it. Let's first of all do this problem, and the next problem is going to be your JEE Mains 2019 problem. All right, just stay focused. Now let's move on to the next problem. This problem should be very easy for you. I told you how to work around such problems. Simply, let's first of all, what is being asked? Okay, let's first of all read the question. Take a moment, try to answer this question. What should be the net dipole moment in this case? 120 degrees between the arrangement of charges. One is plus 2q, the other is like minus q, plus 2q, minus q. Should we get started? What is the difference between this one and the earlier one? Okay. Right. How do you work around this problem? Same thing. You don't have to do anything different, but actually, like, just the calculation should be different. You have a plus q over here, you have a plus q over here, and you have a minus q over here, and you have a minus q. Dipole moment, minus q to plus q to plus. So it's QQ charge pair. So I'm going to call this as something like, P1. This is P2. So the question arises, what is the angle between them and what is the magnitude of? What is the magnitude of P1 and P2? Aren't they same? Same. What is the magnitude, guys? They're going to be Q into A. Okay. This is just the magnitude part. I'm going to call this as P. Next. You know this. This should be like P1. And this should be like P2. What is the angle? 120 degrees, guys. This is your theta, isn't it? This is your theta. Plus 2q charge split into plus q and plus q. Okay, that is it. Now, how do you find out the magnitude? Magnitude, again, the same old thing. P net magnitude is equal to under root of P1 square magnitude plus P2 square magnitude plus that of 2p1 p2 cos theta. What is p1? P, we took it to be p square plus 2 into p into what is cos theta over here? Cos 6. Or sorry, my mistake, it's cos 120. See, it's cos 20. The calculations will change. What is cos of 120, guys? Cos of 120, good. What is cos of 120? Minus 1 by 2. All right, that's it. It's easy. Pretty damn easy, isn't it? That's it. It's p square plus p square. Very good. Minus 1 by 2 of p square. I substitute the value of minus into 2. Right. So yeah, I've just substituted the value of my this is like cos 120 minus 1 by 2, not just 1. So 1 p square gets cancelled. What is the net dipole moment magnitude in this case? Just p. Just what is p? Q into a. That is it. Really simple, isn't it? Simple. This is the magnitude of the dipole. Now, if I'm going to ask you what is the net dipole moment, the direction, how you are going to do it? You need to do the vector calculation. Okay, let's do a thing. Let's quickly do a vector calculation. I will quickly illustrate you how to do this. You have already done it. So P1, this direction, what it is going to be? Q into A into minus of I cap. And what about P2, guys? P2 is going to be like this. Let me do a thing. Quickly erase this. All right. So this is Q into A into minus I cap. And what? Q into A, same P. And this is X. This is your Y. But this negative Y. So basically the same thing you need to do. Right. So this is going to be Q into A into cos of 120 minus I cap. Okay, let me write it down again. I think the space won't be enough, and we will see something interesting, and you will understand what is the direction as well. We'll choose a different color. P2 should be how much? Q into A into time cos of 120 minus of I cap. Does that make sense? Yeah. Why? One would be in plus direction, one would be in minus direction. So this is going to be in plus x direction. This is going to be minus y direction. Okay. So this would be how much? This would be sine of 120 into minus j cap. We basically solve this. What do you get? Q into A into minus of minus 1 by 2. It's going to be plus 1 by 2. I cap by 2. And this is going to be how much? Sine of 120, how much is it? Root 3 by 2. You will get it as root 3 by 2 into. That is it, guys. So if I'm going to ask you what is the net dipole moment along with directions, etc., like what is the equation of net dipole moment? Going to be add this and this. Add 1 and 2. That's it. So if you add it, you may directly write it down. I hope you can understand how to do it. You understand it. Okay. So if I add them, what do I get? I get 3 by 2. Sorry, this is minus. This would be like minus 1 by 2. This would be like I by 2 minus I by 2. This is plus I by 2. This is minus I. So you're going to get minus I by 2 minus root 3 by 2 j cap. Of course, you know, under root of 3 square plus 1 square, that's going to be, sorry, under root of 3 by 2 whole square plus of 1 by 2 whole square. How much is that going to be? 3 by 4 plus 1 by 4 under root 1. Is that correct? Yes. Into QA. Simple question, guys. But get into the habit of writing down some P, etc. It will be really easy. Alright, now let's move on to the next question. This is a JEE Mains 2019 question. Why don't you get started on this first? Until now, whatever concept has been taught to you, you can make use of that concept. Let me quickly explain you the question before we dive into this question. So, what do we have over here? We have plus q on one side of the equilateral triangle, plus q on the other side of the equilateral triangle, which are placed on x-axis. And minus 2q on the other side of the equilateral triangle. It's all placed on equilateral triangle. Now, we need to find the dipole. It's a very easy question. Think about it in a very different way. This question has a little. So this is, you know, like your JEE Mains question. So how would you do it in your exam? This is the way you need to think about whenever you see. Try it out. Among those 4 given options, which one do you think is going to be correct? Let's do a thing. Since this is a JEE Mains question, what we will do is we'll approach this problem not from, you know, all the methods that we have done until now, but rather we'll take a shot based on the options. Okay, it's an option based question, so you don't have to worry about the entirety of like how to get the minus I cap, j cap, etc. But along with understanding the concepts, we're solving different kind of problems. So how do we work around these? Give you a Okay, let's get started with this question, guys. I'm going to show you something very interesting. This is going to be plus q. Okay. We have another plus q on the x. The axes are given to you, answer is given in ij. Notice the thing carefully. How are we going to approach this problem? You need not do the entire thing in this question. Trust me, there is no requirement for that entire. Can we split this into 2 charges? Minus q. One more time. We just did a similar one. Magnitude of this pair, I'm going to call this as pair 1 and dipole having dipole moment P1. What is the magnitude? Isn't it equal to this one? Just the magnitude, of course. It's not equal, but in terms of magnitude, they are equal. Why? Basically Q into L, right? This one is having what? Q, magnitude of charge, into L is the magnitude. Magnitude is the same. Very good. Post that, what you need to do? Are you going to do the entire vector calculation, Nikhil? Sorry, Neelu. Sorry guys, okay. Are you going to do the vector calculation in your exam? Is that how you're going to do it? Let me ask you a question. Okay. So this is just for the exam, but definitely it will be useful while you solve it for the exam. So let me put this in a bracket. Let's move on. We understood both should have same dipole moment magnitude. Okay, how do you solve this question in, like, you know, few minutes? How do you guess the answer in a few minutes just from your given options? Like few seconds actually, if you understood. A matter of seconds. Those were the exact options given to you. Okay, for this SQ. Now, here is one typo. Here is one typo. Let's do a thing. You know, this is 60 degrees. It's an equilateral triangle. Isn't it an equilateral triangle LLL? This is going to be 60 degrees. This also 60 degrees. This also. Doesn't matter. What matters is this is 60 degrees and they are at equilateral position. This is L distance. This is L distance. Now, are you getting an intuition how to do this problem? Just simply say that this should have been the direction of dipole moment. It should be in the minus J direction. Let's verify our option. Only C and minus J net. Rest of them are I plus J. This has like something like I plus J. This has like plus J. Only one option among all of them have minus J. So you can simply in your exam say this might be the answer. This is the correct answer. Anyway, try to calculate the magnitude to come to a final conclusion. That is what I would advise. 60 degrees, we have already done a very similar problem. You would get root 3, you know, into P. So that would be like root 3 into Q. But typically, whenever such questions are given to you, try to assess the direction. First of all, see if any option among them you are able to assess quickly. Easy? Pretty easy? Let's do a thing now. Typically in questions like this, what I would do is I would draw two components. One component of this P1 is going to be like P cos, is over here. I'm going to call P cos 30 minus J cap. Where are we getting this from? We are getting this from P1. What about this? This is going to be again minus J cap. There is no difference in that. Along y direction. It's going to be again P cos 30. What is the value of P, guys? P is Q into L. Now, what is this? P sine 30. This is 60 degrees, right? So this would be 30 degrees. If you have missed this point, just explaining this. Okay. The entire thing is 60 degrees. There is going to be an angle bisector and it's going to be 30 degrees and 30. Yeah, is it easy? It's an easier method, huh? But yeah, but it's important that you understand all of it because this was one question, right? You may not necessarily get your question always this way. So this is going to be P sine 30 I cap and this is going to be P sine 30 minus I cap. Cancel out this and cancel out this. If I'm going to talk about net dipole moment, you're going to add up all of these components. Two are going to get cancelled. What is P net now? Just, you know, guess it from the diagram. It's going to be minus 2 P cos 30 J cap. The moment you see this problem, you should be able to guess the answer from the options. If not, this is a little easier way of doing things. Right? This minus 2P, what is cos 30? root 3 by 2 j cap. How much do you get this to be? 2 gets cancelled out, so it's going to be minus p root 3 j cap. And what is p? It's going to be q into L into root 3, and there will be minus j. Okay, I hope you understood this. And substitute the value of p and you'll get the answer. Alright guys, simple. Yes, Abhi, there is so a good question from one of the students. Are there separate batches for JEE Mains on Unacademy Plus? I am a Plus student and only wanting to prepare for JEE Mains. Yes, of course there is. And from next week we'll be also starting some JEE Mains program for you on Unacademy JEE English as well. But yeah, be sure to subscribe in those courses where there are like dedicated JEE Mains. Easy. Pretty damn easy. This is a JEE Mains 4 marks question, guys. If you'd have understood a small, not the entirety of like calculation, but it should be in the mind. That is why the direction was very important. It should be in minus j direction. You would have simply eliminated and sent the answer. I need to check it out, Abhi. But from next month, we'll be having dedicated JEE Mains program that will be going on. So are you a 2021 aspirant or a 2022 aspirant? There are, of course, JEE Mains batch on Unacademy Plus as well. Which one are you, 2021 or 2022? Yeah, for your program will be starting from Monday for 2022 aspirants. And yes, you also have Plus program. Plus is going to be a little different. You'll have test series to attend. So definitely I recommend doing also test series for your JEE preparation. But as such, for lectures you can attend them on JEE English as well. It will be starting from, for your physics, it will be starting from Tuesday onwards. You have a 2022 oriented lecture every day. Okay, you can start attending them. Alright guys, get started on this problem. This is an interesting problem. I hope you got your answer, Abhi. Okay. What do you think? How should you approach this problem? Forget what do you think and etc. How should you approach this problem? You are welcome, Abhi. You are welcome. Guys, do the vector. Trust me, do the vector. You will see the question is a lot easier than what you think. If you want to try out the problem once on your own, just try it out for the given system, for the given charge configuration, what it should be. Do a thing. Let's get into this problem. So I'm going to do one thing to standardize things. Just I'm going to say P is equal to, so since just a moment, this is of side A, this also of side A, everything is side A, side A, side A. So one thing you need to remember is, or one thing you may want to do even in your exam is say something like P is equal to Q into A. Some quantity, not necessarily some dipole magnitude, because how many dipoles exist over here? You can take this, minus 4q to be something like minus q minus 2q and another minus q. Okay. So one dipole exists in this direction. Just for now, try to understand it. I'm going to, teach you a very simple method of dealing with this problem. Just focus, give it a couple of minutes, have a look at it. I've split the charge, first thing I've done. And you can choose the pairs as you like in some questions, but in this question, typically this is the only way possible. In future questions, you can do them, but we will adapt a very simple method of solving. Okay, what did I do? I split the charges, I identified the dipole pairs, and I wrote P is equal to Q into A. This is just a constant that I'm defining for now. You'll understand why. This minus Q and this plus q. What is this dipole moment? This is p into minus I cap. Minus 2 positive. What about this, students? This is going to be p into minus j cap. Let me draw this of you. So anyway, you know the side is a and not write it down. This is going to be how much? P into minus or plus j cap, negative to positive. Now comes this one. Okay, let's do a thing. See, this is not p, right? Or this is not 2 into p. Try to understand this point. Let me call this as a new dipole moment having a dipole p3 in this direction. We can later on define this p3's magnitude, etc. So one way of noticing this problem, the easiest way according to me, is split it. Split it. It's very easy to understand how your dipole should be. And the other way is like writing down what is this going to be and then using the angles to calculate it. But there are 3 dipoles. It will become a little bit complicated. So what you need to do in such cases is, according to me, you can choose whatever way you like. But I'm going to do something like this. I'm going to split this dipole into 2 components. One component, as you know, it's from minus to positive, right? One component would be in this direction. One component would be in this direction. Simple? Easy? So this is going to be minus 2q into something something. Let's calculate it later. But for now, I'll give you a small hint. That hint is nothing but this distance is not a. How much is this distance? This is a, this is a, this is a 90 degrees, right? This is a 90 degrees. And how much this should be? Root 2a. The distance between this plus 2q and the split up minus 2q should be how much? Under root 2a. Okay, so magnitude of P3 is different than P1 and P2. In fact, P is equal to magnitude of P1 and magnitude of P2. But it's not equal to P3. That's the reason I kept it all alone. Let's come to this point and let's understand this easy problem. Now this is what this should be like 45 degrees. This should also be obviously 45 degrees, right? So this is going to be how much? This should be 45 degrees, right? So that would be P of P3 of magnitude of P3 of cos or sine. You can take it as anything you like, since it's a 45 degrees angle. You need not worry about it much. In this case, I'm defining this as, you know, cos 45 degrees minus I cap. Very good. Root 2a. And what about this? P3 sine 45 minus j cap or plus j cap. It's plus j cap. It's not minus j cap. Simple. Add them all. First of all, we need to find out the value of P3 in terms of P. P3 is how much? P3 is, what is the magnitude of charge in this case, students? 2q, right? Going to be 2q. This is plus 2q. Here we have minus 2q. This is the dipole pair. So it's going to be 2q. 2q into how much, guys? What is the distance between these charges? Diagonal, which is going to be root 2a. So we can say something like 2 root 2 qa, which can be written as, further, this can be said something like P3 is equal to How much, guys? P3 magnitude. We are just talking about magnitude. Remember that this is all about magnitude. P3 is equal to just a moment. Let me write it down again. P3 magnitude is equal to 2 root 2 P. Since P, we have given it a name like, you know, QA. We have defined P is equal to, so just for convenience. So now the question is really simple. Just add P1, P2 and P3. Right, some of you have already got the answer. If not, let me just do it for you. Okay. So P net was how much? P1. Okay, I'm going to call this as P1. This as P2. And this one as P3. P1 plus P2 plus that of P3. Now P1, we know it is something. Okay, this is P1. Okay, it is how much? P into minus I cap. How much is P2? I believe it's P into plus J cap. This is P2. Okay, this is P into plus J cap. And then we have P3, which is split into two components, which I'm going to write down as like P3. Let me do a thing. This space, keep it as P3 for now. P3, write it down over here just for better understanding. P net is going to be P minus I cap plus P J cap. It's a pretty easy problem, guys. If you understood it, it's amazing, right? Hold on. This is P into J cap, and this is going to be how much? P3. P3 is split up into two parts, which is going to be P3 a cos 45 can be written as 2 like root 1 by root 2 minus I cap or plus J cap. Minus I cap, and we need to write down this component as well, which is going to be P3 plus P3 sin 45 plus J cap or minus J cap. It's going from negative to positive. Think about it. It's plus J cap. Substitute the value of P3. How much is P3? P3 is how much, guys? P3 is 1 by we had to substitute the value of P3. P3, if you remember, it's 2 root 2P. Just the magnitude of P. 2 root 2P. Okay. All right. So 2 root 2P into 1 by root 2 minus I cap plus of P 2 root 2P into sin 45 1 by root 2 plus J cap. Root 2 gets cancelled, root 2 gets cancelled. What do you have left over? We'll just carry it on to the next page. Yeah, I hope you are taking down the notes. It's a simple one. I'll show you some easy methods of working around such problems. Okay. So first of all, always standardize some things, and that will become really, really easy. P net is equal to P into minus I cap plus of P into plus J cap. plus of p into, sorry, 2p into, we have root 2 cancelled out, we will have 2p into minus I cap. And again we will have 2p into plus j cap. Right? Alright? Root 2 cancelled out, 2p j cap. Add them up, guys. Add them up. It's a very simple problem. What are you getting? Minus 3. Okay, let me keep it as not minus. Sorry. Let me keep it as just plus. Let me write it down neatly in a different color. Yeah. I'm going to add this and this. That's what I'm going to do. So we get P net to be like 3p minus I, and this two added 3p plus j. That is it. That's the vector. The vector P net dipole moment of the given system. Net dipole moment of the given system. What is being asked, the question is, in this case doing it in the vector form was pretty easy compared to calculating the magnitude. You can otherwise do it the other way as well and still get the answer. One of the best ways to think about it is, this two added up will give a very similar type. I'll come to the shortcut method if you can intuit it from the question itself. Okay, so this would be how much? 3p root 2. What is the value of p? P we had written it as q into a, if you remember. That is it. Just substitute that value. So you will be getting 3 root 2 into qa. Sorry. 3 root 2 into qa. Now, I hope you understood this method. I'll come to a very simpler method. Can you think of that method what I was talking about? There is a very simple method, guys, to solve this problem, because you need to have that thing in your mind how to quickly get to that solution. They're all JEE aspirants, not be like, all right, I know this is how you need to do, and this is how I'll be moving in my exam. I said no. Let me give you a shortcut. Okay, this is pure understanding, guys, pure understanding of the things. Okay, let me give you a small shortcut to work around this kind of problems. Okay, this is P. I'm going to redefine this. It's Q into A, and we know one more thing, P3. P3 is what? This distance was 2 root 2A. So P3 is going to be 2 root 2 into 2. So sorry, 2 root 2p. So it's 2q into a root 2. So it's going to be, this came from p3 is equal to, magnitude of p3 is equal to plus 2q into a root 2. From here we wrote. Now what is the shortcut? This is p. Some vector like p1 you can think it of, but I'm giving the direction and I'm defining the direction, and I'm giving like all the directions properly. So try to intuit this thing. What is this? P. I'm not talking about p3, guys. I'm just talking about p1 and p2. I'll come to p3 later. Okay, this is p1. This is P2. Net of P1 and P2 is something in this direction, the same direction along P3. The same direction along P3, this P1 to P2 exist. The net of P1, P2 exist in the same direction. What is the net of P1 and P2? This is just applicable in this case, not in every case, so think carefully. Okay. If at all even the charge magnitudes are changing, you need to think about different approach. This is going to be how much? Root 2p. Add them up. Same direction of p3. Where was your p3, guys? your P3 was also in the same direction. Yeah, absolutely. That's it. That is it. How simple is this problem? You need to think a little bit, in vector direction. You would understand P net is equal to P1 plus P2. So I'm not talking about, in fact, all the directions yet. So we'll just keep it as mod. In this case, it was magnitude was asked. So there is a little simpler way of doing this problem. So that would be how much? Root 2p plus 2 root 2p. Okay, this 2, let me do it this way. When I erase this, you understood this part. So I'm going to keep this. This is how much? Root 2p plus of p3 is written over here, 2 root 2p. P net's magnitude should have been 3 root 2p. This is just for your understanding, guys, how to quickly solve this problem, not going method by method, step by step. This is how you would solve the problem. Okay. Alright, this would be useful. Okay, taking standardized things, it will really be useful. Now, why don't you try out this problem? This is a very interesting problem. Have a careful look at the problem. Now there is little bit, changes in the problem. This is minus 3q and this is minus q. This is plus 2q and this is plus 2q. Try it out on your own once. Try it out. Take like 2 minutes. I'll wait for 2 minutes. Try it out on your own. Post that I'll get started. Okay. Try it out on your own. Get started, students. Get started. Put your pen on the paper. This is a very easy problem. Just try it out on your own. Try it out yourself, students. This is a simple problem. Just assess few things. You can quickly solve this problem. You just join the class, do attend the entirety of the class. It's a very important topic. Direct questions come in your exams, and also to understand the shortcuts. There is an interesting proposition in this problem. There's a very quick way of solving this problem. Alright, let's get into this problem. I think you can try it out. If you are still trying it out, not a problem. Let me do a thing. Let me first of all do some charge analysis. This is plus q. I'm going to say this is plus q and I'm going to split this into 2 plus q's. Okay, either way you can work around it, but I'm going to just split this into 2 plus q. And now what I'm going to do is I'm going to have a minus q over here. Okay, this minus q. Okay, and of course, why did we do this? We have a dipole moment. Okay, I'm not yet defining things anyway. But let's say, let's do our usual thing. Let's say P is equal to Q into A, just for convenience. So what is the dipole of this system? This is Q into A into minus J cap. This is negative Y, right? This is in minus J cap direction. Okay, you understood that. Now next comes this system of charges, or let's do a thing. Let's not call it Q into A, but rather keep it as P. Okay, because we don't want to write Q into A all the time, and this is a simple way of doing your things. And next we have something like this guy. this guy, which I'm going to split up into two. One is going to be minus q, and the other one is going to be another minus q. Sorry, another minus 2q. Uniform. What I'm going to do is I'm going to split up this guy. Reason to assess our dipole moment. Dipole moment of the system exists minus 4q plus 4q. Hence dipole of the system exists. The configuration does not matter. So this I'm going to call as minus q, right? And this is going to be like another split up. That's going to be minus 2q. Now this is going to be what? This charge plus 2. Notice this question carefully. It's a very easy question if you understood the method. Quickly show you some method. Okay, and due to this pair is already done, right? This and this pair is already done. This dipole is done. Now what we are focusing on is this pair. What is this pair giving you dipole moment as? Some p into negative to positive minus I. Now what about this? It's the same distance A, right? So this is going to be P into, or 2P, it's 2P because it's 2Q into A, right? Here it is going to be 2Q into A as the magnitude of the dipole. If 2Q can be written as 2 into P. 2 into P into plus J cap. Notice a very interesting thing over here. Pull this out. Simply cancel out. What did I do? This is minus J cap, this direction. Cancelled out with 1p J cap in this direction. What is left over? What is the net dipole moment in this case, and in which direction it is? Minus I plus J direction. Simple. Just write it down. Net dipole is in this direction, and that's going to be how much? P into 1J and P into 1 minus I. Don't need to go through the struggle of doing everything. This is a simple way of solving the problem. That's it. Resolve the components, try to understand the problem. It's pretty damn easy. Promise you, but you need to focus on the class. It's a simple one. So what was our P net that we derived just from the figure? It said that the P net is equal to some P into J minus I. What was P? P was something like Q into A into J minus I. We define this P, we standardly define this. Just let this not. The answer is given to you, you're going to mark this. But magnitude is being asked. So it's also simple. What should this magnitude of this be? QA into root 2, right? QA root 2. Simple. That is it, guys. That is it. The answer was 2. Okay, whatever. I believe you understood this problem. It's a very simple problem, but the key game in this problem is understanding that vector, how to apply it, when to do this component resolving, when not to do it, when to use I cap and J cap, and first of all assess whether the system is in dipole moment or not. With this we'll come to a very interesting problem. Okay, this problem also has a similar thing. but given that, you look at it. So this is a dipole system, right? This is a dipole system, isn't it? 3q minus 2q minus plus q and minus 2q. So net is 0. This is a dipole system. Dipole of this system is being asked. Said that this distance is a and a. That is what is given to you in the question. Okay, try it out yourself. Post that, let me get started on the question. There's a simple way. Do it the same way that we did earlier. You'll find this answer very quickly, very easily, and very interesting. Shall I get started then? It will be done very quickly. Okay, first of all, let me define some new quantities now in this case. This is anyway, this is given to you as a and a. So I'm going to call this as L, which is nothing but root 2 a. Okay, I'm going to call this as L. This a 90 degrees. This is L. Okay. So first of all, let's define this thing that Q into L is equal to P now in this case. Okay, just a convenient term that we define as usual. But do remember, this is root 2a, not a. Okay. This is how much? L is how much? L is root 2a. Now comes the problem, how to solve this kind of problem. Minus 2 plus. Split this charge into 2. One is going to be plus 2q and here another plus q. And split this charge into 2. Okay. This is going to be minus q. This is going to be a minus q. Well, there is a very simple method of solving this question. So if you go around this, not by much effort, just draw another dipole from here to here. How much is this? This is root 2a into 2q, which is basically 2p in this direction. Okay, this is p in this direction. Opposite direction, directly cancel it out. That is it. Simple. And what is left over here? It's something like another. This should be from minus q to plus q. Okay. This is okay. So 1p in this direction, 1p in this direction. What does it look like? If you draw it, it's going to look something like this, which are going to intersect each other at an angle of 90 degrees. A P and a P in 90 degrees. P and a P in 90 degrees. What is that going to give you guys? What is the net resultant of this vector addition? I'm just going to talk about magnitude. I'm not worried about the entirety of the calculation. It's going to be root 2p. Root 2p, very simple, right? Just draw this 2p, draw this p, draw this p, you will get the answer. Does 4p exist? Yeah, 4p exists in total. But 1, 2p and the p got cancelled due to the opposite direction. Right, substitute the value of p from here and here. That's going to be root 2 into how much? Q into L. L is how much? Root 2a. How much is this? 2qa. That is it, guys. That is it. That is it. End of the story. That's it. Don't put in much efforts. You can do it very simply. Alright. I believe this concept was really clear. Now let's come to that interesting part of our question. So yes, charge enclosed in a dipole system. So dipole can be like very small, you know. can be, it has to be very small, right? The distance between the charges has to be very small. It can be even like this. The arrangement need not be necessarily like this, what you're seeing over here. So it can be something like this. So in this case, like the charge enclosed by this system is going to be how much? 0. But do remember, dipoles have electric field, right? Dipoles have electric field. I'm just coming back to the question that was discussed in the beginning. Dipoles have electric field, and that means Gauss law cannot be applied, because Gauss law says flux, which is nothing but electric field into area. Of course, area of this Gaussian surface is not 0. Area of this Gaussian surface is not 0. It, according to Gauss law, it says that charge enclosed is 0. So that means phi is equal to E into A is equal to epsilon naught. This is the flux definition. This is the Gauss law. As you know, phi is equal to Q by epsilon naught. That means this should be 0. That means electric field should also be 0. But we know it that dipoles have, electric field. Thus, Gauss law cannot be applied on dipole. The statement is correct. Okay, what I mean is Gauss law cannot be applied. An electric dipole does not have symmetrical distribution of charges. Do remember that it has to have symmetrical distribution of charges for Gauss law to be applicable. So both A and B are correct, and B is the correct reason for A to be true. Alright students, that being said, Unacademy Combat is back. The most competitive gamified IIT JEE battle is here. You can compete live and win lots of rewards and prizes. Yes, it's not just going to be a rewarding experience, but also an amazing experience for your JEE Mains and JEE Advanced preparations. So be sure to participate in it and compete live to win lots of rewards and prizes, and enroll today with Murli Live Code. Make sure you apply Murli Live Code and attend this event on 6th of December. And students, you can win MacBook Air, Apple products, hundreds of Amazon vouchers. And that being said, students, if you are already on Unacademy Plus, just enroll soon to this Optics Basics to Advanced coursework, a comprehensive coursework on optics, which starts from basics, where you don't have to know anything, and it goes up until advanced. So make sure you are attending this optics based coursework, and it's all like a complete package for your optics, a comprehensive coursework in which we will be covering both ray optics and wave optics, and it has just been launched. And if you're planning to purchase an Academy subscription, do it soon and enroll to this coursework. Not only that, our amazing JEE English team is also on Plus. We have started courses on optics B2A, basics to advanced. So basics to advanced, you don't have to know anything. And even if you can also attend the recorded classes. And guys, our amazing team is also on Unacademy Plus. Like I have started courses on optics. We have another physics course going on electromagnetism and differential calculus and chemical kinematics. And yes, our amazing team has also started, 2022 aspirant oriented plus courses on graph sets, relation, reduction, equivalent concept, and on mechanics. So you can learn in English also on plus from our platform. Not only that, guys, there is a Google batch for droppers which has just begun for JEE Main 2020 and JEE Mains 2021 aspirants, which has begun on 20th of November. And there has also been a micro class that has just been started for 11th class on 20th of November by our Unacademy team. And do not forget to like this video, do not forget to share this video because someone in need may get access to quality full-length lecture for the JEE preparation. So think about it. We are discussing important and really important problems for you. And also do not forget to click on the bell button and subscribe button and work hard. And this is the moment 2021 aspirants not just work hard but also work smart for your JEE preparation. So make use of these strategy sessions and think about how you need to prepare now, and keep smiling, acquire knowledge and share this video. And that being said, students, if you are not yet on our Telegram channel, do get onto our Telegram channel, and you need to first of all download Telegram app from your Google Play Store and App Store, and then click on to this link which is available in the description box below. And you can just type in JEE_English also to find us once you download the Telegram channel. Yes. What do you get over here? You get before time, before time, on time updates on every class that is being conducted on JEE English or any class our team conducts on Unacademy Learning App. And that being said, this Sunday from 10 a.m. to 1 p.m. we will be having a special class, a free of cost special class on problems and PYQs on capacitors. So be sure to attend them, students, because it's going to be a complete kind of revision for your capacitors. And not only that, if you want to attend all of the capacitor sessions, just to attend A to Z capacitor sessions, where we have conducted 6 lectures, where I've conducted 6 complete lectures on capacitors. So if you at all attend this capacitor lectures and electrostatics lectures, your preparation for JEE is complete. So make sure you are attending A to Z lectures on capacitors, all the 6 lectures on capacitors. And also, guys, do not forget to attend this 10 a.m. session on this coming Sunday, a special class for your JEE preparation. So yes, do download Unacademy Learning App if you don't have one, because these are classes happening on Unacademy Learning App. I conduct A to Z lectures on Unacademy Learning App. And that being said, students, we have also completed units, dimensions and measurements on your Unacademy Learning App. So what is this A to Z units, dimensions and measurements? It's that 4 plus 1. Okay, 4 concept plus problem and 1 problem session, 1 complete problem session, where we have discussed the entirety of units, dimensions and measurements. Units based problem, dimension analysis, measurement based problems like vernier calipers, screw gauge and error analysis, least count. Be sure to attend them. Even 2021 aspirants, don't ignore them, saying that it's not at all a useful chapter, but it's a very useful chapter, because you're preparing for JEE Mains and JEE Advanced. You typically get 1 question every year in your JEE Mains. Combine your JEE Mains and JEE Advanced, you get 3 questions. So definitely attend chapter. And not only that, guys, the experimental part is included in this, and you can get a combination of question in your JEE Advanced. So be sure to check out my lectures on Unacademy Learning App. Be sure to follow me to get live updates. But that being said, attend this session, and 2022 aspirants definitely attend it. And yes, if you don't have an Unacademy Learning App, just type in Unacademy in your Google Play Store and App Store, and then click on to this link and install them, so that you can get live updates on every class that is happening on Unacademy Learning App, and also follow me to get live updates. Not only that, guys, you can attend amazing quizzes, amazing live quizzes that are being conducted at a national level and also on Academy Combat. So do install that app. And that being said, if you're looking for a champions tool for your JEE Mains and JEE Advanced preparation, it is going to be an Unacademy subscription, because you will get to learn from the best educators across the nation on an Unacademy subscription in a structured program, intensive and extensive structured program. So you don't have to worry about the kind of program that you need to have for your JEE preparation. This all comes at also a very reasonable cost, and think about it, and on a best platform. What do I mean by structured program? You will have dedicated doubt clearing classes, you will have quizzes, mega quizzes, you will have this on the best program with the best educators on the best platform. All you need to do is click on the left hand top corner extension bar, choose IIT JEE, and click on this get subscription button. Guys, once you hit on this subscription button, do remember it's 1 subscription, unlimited number of access. And students, the price is also pretty reasonable. It comes at a price of less than 2,100 per month. 70 rupees a day is what you have to pay for a 24-month package by applying Murli Live coupon. So be sure to apply Murli Live coupon to get the best discount on your subscription purchase. And this is a 24-month program meant for 8th, 9th, 10th and 11th class students. And that being said, you can also make use of convenient payment options to split your payments into multiple parts. You can use our pay in parts option and no cost EMI, using which you don't have to go through the burden of paying all the fee at once, and you can split your payments into multiple parts and pay them easily every month, and using easy monthly installments where you don't have to pay any interest. So check out both of this option. We also have debit card, credit card and UPI. And that being said, if you're a dropper or a long term, you may want to go for a 12-month subscription, and typically this is meant for droppers, long term and 12th class students. And this all comes at a price of less than 2,900, a price of 2,888 only. Apply Murli Live coupon to get the best discount, and to this price point. This is a discounted price point, so do not miss out discounts. Apply Murli Live coupon, get the best discount. And what do we have for droppers? Dedicated programs, 6,000 plus materials and 1,000 plus live programs going on, and hundreds of programs going on every week. And that being said, students, there is plus subscription. There is also an iconic subscription. An iconic subscription is where you will get personal coaching. Additionally, you will get personal coaching and study planner, expert guidelines, along with live quizzes, test series, structured courses. India's best educators will have interactive classes also on iconic subscription. But the best thing is you will get personal coaching, study planner and guidance from IITians and IITians who have previously cracked IIT JEE, and they know what you need to do to get through this, to get through this journey. And this all comes at a price of only 50,400 if you are going for a 12-month subscription. If you are going for a 24-month subscription, this is going to come at a price of 77,400 only. So you have to pay less than 51,000 if you're going for a 12-month subscription, and you have to pay anywhere around less than 78,000 for your 24-month subscription. And be sure to apply Murli Live coupon on any of your subscription purchases to get the best discount. So make sure you avail the best discount. Make sure you're taking advantage of this lecture. Share this lecture, like this lecture, and also make sure you're sharing it on your social media, WhatsApp, Facebook, and whatever social media you use, Telegram, etc., because someone in need may get access to this amazing lectures, guys. And our team is also on iconic subscription. We have IITians and IITians and head of institutions on this team, and guys, we will take you to the next level of JEE preparation with our personal coach. So you will get IIT JEE workshops, expert guidelines, test analysis, study planner, all in with our iconic subscription, that too in English. That being said, stay safe, take care, stay safe, but be regular to your lectures, because that is the way to crack. So take care, stay safe, bye bye, see you in the next class, students.